Welcome to qnawire.
The period of precession T is related to the reciprocal of the angular precessional frequency by this, and we will use equation 11.13c for the precessional angular velocity, which is capital omega here. So from this equation we have capital omega to be equal to mgr over I omega. Now we can substitute this expression into this equation. So we have T equal to mg 2 pi I omega over mgr. And since the gyroscope has a disc shape, I will be equal to half times mass times radius of the gyroscope or radius of the disc square. Now we have r of the axle is equal to half of the length of the axle. So this will be equal to 0.105 meter. Make sure you write all the variables in standard units to be consistent with the equation, to be consistent with all the units. So we plug this expression of I over here, and we can also write omega to be equal to 2 pi times frequency, and frequency is given to be 45 revolutions per second. So doing that, we get mgr Now we can simplify this expression a little bit. So let me do that on the next page. So T will be equal to, so this 2 over here and this 2 cancel out. So now we can write T to be equal to 2 pi square f times square of the radius of the disk over gr. So notice that the mass terms also cancel out. Now we can solve this equation. So we have frequency to be 45 revolutions per second. Radius of the disk is 0.055 meter. G is acceleration due to gravity, and small r is 105 meter. And this is equal to 2.611 seconds, which gives the time period. So this is part A. Now for part B, we have to find the ratio if the radius are doubled. Now we will use the relationship, this one that we derived. So let me put it in a box. So this is the expression that we will use for part B. So therefore we can write now T new over T old. So T old refers to the variables we used for part A, and T new refers to the time period for the new variables in part B. So this will then be equal to 2 pi square frequency, which stays the same, r disk new over g of r new over 2 pi square f r square of disk old over G R of old. And many of the terms will cancel now. So these three cancel, G also cancel out. So we finally arrive at square of the ratio of the radius of the disk and also times the ratio of the old radius over the new radius. And this will be equal to, since the new radius is twice of the old radius for the gyroscope, this will be 2 over 1 square. And for the axle, this is 1 over 2. And this gives T new over T old to be equal to 2. So this gives T new to be equal to twice of T old. Now we can use our answer from part A and substitute this into T old, and we get T new to be equal to 5.222 seconds.